All right, this is the last transformation of the functions that we're doing, and it's a little bit difficult, so there'll be times where I just put it down and then pick the camera right back up. So the first thing is that an inverse function is where the inputs and the outputs exchange. And so we can do the same thing in our equation. In our equation, we can just replace y with x and x with y. And then solve for what y is to get an equation for my inverse function. So we need to solve this for y, so the first thing we would do is add 5 to both sides. And then divide both sides by 2. And we can rewrite this as, so I'm going to write over here, y is equal to, that's the same thing as x divided by 2 plus 5 divided by 2. And to help graph it, I can write the slope. So it's a little bit more obvious what the slope is. I can write it as 1/2 times x plus 5/2. So we can graph that equation using the slope and the y-intercept. So do that. I'll do the same. Okay, so you really only need to plot 2 points, but I went ahead and plotted 3 just to help me get a better line. So you can start at 5/2, and you go up +1 and over 2, and then I went up +1 again and over 2, and then I just used a straight edge to connect those dots. We can tell that it's an inverse because we can see that the coordinates switched on it. So for example, if I take this point right here, the point +3, +3, +1, I can look on my inverse function and I can see that the point +1, +3 is also is on the inverse function. And that's because on my inverse function, the input becomes +1 and the output becomes +3. When before on the original function, the input was 3 and the output was +1. Okay. On this one, the way we write it in f of x terminology is we write it as f to the -1 of x. So our inverse function of f is equal to, in this case, 1/2 x plus 5/2. Okay, that's not to be confused with when we raise a number or an exponent to the -1. So just a side note. Whenever we do like +3 to the -1, that means 1/3. Or if we did x to the -1, that would mean 1/x. That's not what this means. This is just the symbol that we use to represent the inverse function. Okay. Here we want to show, and we can use our equation to show that this is true, that f evaluated at 3 is +1. So I want to evaluate f at 3. That means to plug 3 into our original equation. So our original equation was 2x minus 5. So I'm going to plug in 3 for x. So 2 times 3 minus 5. 2 times 3 is 6, minus 5, positive 1. F to the negative 1 evaluated at 1. So the inverse function of f evaluated at 1, I can plug in positive 1 into my inverse equation, and I get 1/2 times 1 plus 5/2. So that's 1/2 plus 5/2, which gives me 3. Okay. And then the next thing that we do, so just notice that here my input was 3 and my output was positive 1, while over here when I put in 1 into my inverse function, the output was positive 3. Same thing that we noticed on the graph.
Okay, then I'll go with this.
And so then now what you should do is plot the line y is equal to x so we can see how these two graphs are related. So I'm going to do that in just a sec. Okay, so the line y is equal to x just crosses through the origin and has a slope of 1. I made my line dotted just to keep it separate from the other ones. And so what other people had noticed about the graph was that it cut the distance between the two lines in half, and that it also intersected the same point there. And the most important thing to notice is that it's a reflection across that line. So when I look at, and this is going to be difficult to show, when I look at when I hold a mirror up to that line, we can see that it's a reflection of that. Let's see if it works better the other direction. That my inverse and my original function are both reflections of each other. You can kind of see it a little bit better there.
Okay.
Please ignore my family. So it's a reflection. It's a reflection across the line y is equal to x. Okay, so that's true for all inverse functions. It's always a reflection across this line. So then on this parabola that's given to us over here, we can graph the line y is equal to x again, and then we'll graph the inverse function. So go ahead and graph the line y is equal to x, and I'll show you a trick. Okay, I'm going to go ahead and make my parabola a little bit darker so that we can see it better in the mirror. Okay, so it's going to be a reflection again across that line y is equal to x. So what our inverse function is actually going to look like is a sideways parabola. Okay, so we need to draw that, and the way we can do that is we can look on our original parabola and pick a point. So like this minimum point is the point +2, +3. And we can just switch the inputs and the outputs and plot that point. So now what we're going to do is plot the point 3, +2. So 1, 2, 3, 1, 2. So that's 1 point on my reflection.